Controls and variables slideshow with you. We're going to start with scientific method, which hopefully is mostly review for us. First step is going to be observation. You make an observation with one of your five senses, so it's something you know for a fact from seeing, touching, hearing, tasting, and smelling, which we won't be doing those last too much in science, but it's definitely something you know by a fact from one of your senses. And based on those observations, you generate a question, and it has to be a testable question. And that leads us to step 2. In step 2, you form a hypothesis. You've probably been taught that's an educated guess. It's not the best way to learn that. It's okay, it'll let you kind of know what you're going. But really, a hypothesis is a testable statement that can be supported or not by data that you collect. Oftentimes you'll revise it. It's no big deal if your hypothesis was wrong. You still learn something, but the key is it has to be testable. The Browns are going to win the Super Bowl this year. That's not a hypothesis. You can't test that to see if it's true or not. A good hypothesis will be written in this form, and we will practice this if-then statement. Oops, clicked something I shouldn't have. For instance, if the height an object drops from is raised, then it will fall faster or slower or won't affect it. Any of those would be hypotheses that follow that if-then. So if one thing happens, then another will happen as a result. Go to pause this while you put this into your notes. Step 3 would be experimenting. You actually test your hypothesis, and you have to do this under controlled conditions, where you have one group that's a control group that you're comparing things to, and the experimental group that you're changing one situation with, which we'll get more detail in here. So in your experiment, your two groups are exactly the same, except for one factor. And that one factor is the independent variable. Notice it starts with I. If you're doing the experiment, pretend it's the thing that you change. So I change it, then it's the independent variable. The other group, the dependent variable in an experiment, is either what's being measured or tested for, or it's the thing that changes on its own as a result of that independent variable. We'll practice a lot with that. So the factor that you change is called the independent variable. What you're testing for or measuring is the dependent variable. When we are measuring our data, we're either going to have quantitative or qualitative. If you look at this word quantitative, it looks like quantity, which is a number. So quantitative data deals with numbers. Qualitative is descriptive. It's describing something. You might want to describe the migratory pattern of a bird. Numbers really wouldn't be good, quantitative data, but qualitative would. You might notice that between October 1st and October 3rd, this certain type of bird always starts to leave the northern states and fly toward the south. Go ahead and pause while you add this to your notes. Step 4, after we've done our experiment, we have to organize our data. We're going to put those pieces of data that we've collected into graphs, charts, tables, or maps, which we'll be doing a lot of this school year. Step 5, from the data that we've organized and collect, we draw conclusions. Remember, they're based on facts, not observations. They're drawn from data. They should support the hypothesis or not, but they should definitely be retestable. You should be able to get those results repeatedly. Other people should be able to get those results through this step. Step 6 is communication. You have to share your studies with others in scientific journals. The reason being is scientists should be able to repeat what you've done. So if you think you've discovered something, you list how you did it, what you did. Other scientists do the same thing, and hopefully they get the same results, because then they're supporting your conclusion. Go ahead and pause while you add this to your notes. If you want, you can Google search this and listen to it, but when we are doing catch-up, you were absent a day work, I don't make you watch this. All right, Control variable. We mentioned independent variable, the thing I change if I'm doing the experiment. Dependent variable, what I'm testing or measuring. The control variable are things that are kept constant so they don't affect the outcome. Sometimes they're called constants. So control variable or constant would be the same thing. Why do we have this? If they're not being tested, what's the point? The point is to make sure everything's the same in experiment except for one variable. If we change two variables, if I want to see how adding sugar to a plant will affect its growth, if I add sugar and more water and the plant grows taller, well, I can't draw a conclusion. I don't know if it was the sugar or the more water. So in that instance, we would only want to change the amount of sugar and keep everything else the same, like the amount of water, the amount of sunlight, the soil type, that sort of thing. It says here that you want to do more than one trial when you're testing each independent variable. And, oops. The reason being, make sure they're repeatable. If I were you, I'd actually pause here, read through this. Well, actually, I'll do the first one with you, and you see if you can get the second and third right before I show you those answers. These are the kind of problems you could see on your first quiz. Does heating a cup of water allow it to dissolve more sugar? Temperature of the water is measured in degrees. Amount of sugar is measured in grams. All right, how the heck can I figure out the independent, dependent variable, and constants? First thing, remember, independent starts with I. What do I change in this scenario? Can I add heat to a cup? Can I do that? Or can I make water dissolve a certain amount of sugar? Yeah, I can't make water do anything, but I can add heat to it. So the independent variable would be the heat. What am I testing for or measuring? The amount of sugar. So dissolved sugar, amount of sugar, or dissolved sugar, either one of those would be fine. And constants are things that are kept the same. So what would be kept the same here? Notice it doesn't give it to you, so you have to kind of think with those. But things like that could be the amount of water, heat source. So those kinds of things would have to be the same. Celsius, measuring in Celsius, would also be one. Try the same with the next two. Pause while you do, and then I'll show you the answers on the slide after that. Go ahead and add this to your notes, and once you're done with that, you can go ahead and do the review games.